In this lesson, we're going to be looking at exponents and how do we evaluate exponents, and looking at several different properties used to evaluate these problems. So first we need to talk about what is an exponent. An exponent is a number that tells us how many times we do repeated multiplication on the base. Okay, in a problem, it's that small number that's above the base number and to the right of it. So here we have the example 2 to the 5th. 5 is our exponent. Okay, and then we have our base. The big number, our base, here would be 2, and that's telling me that I'm going to take that base number 2 and multiply it by itself 5 times. Okay, so that would tell me to do, say, 2 times 2 times 2 times 2 times 2. And work that out and I can get an answer. Now, we can do some evaluating with these exponents, and there's several rules. These rules are very important that you learn. You will use these rules throughout the rest of this year in Algebra 2. So the first rule is the product rule. If I am multiplying two exponents, now again, it doesn't matter, it does matter. In order to use the product rule, my base has to be the same number. Okay, so here is A. This is just a representation. But in order to use the product rule, if I have the same base and I'm multiplying these two things, then the product rule tells me all I have to do is I'm going to keep that base, and then I can add the exponents. So x to the third times x squared. Again, my bases here are the exact same, x and x. So that means that all I have to do then is take these two exponents, add them. 3 plus 2 gives me x to the 5th. The power rule is if I have a base to an exponent like a to the x, and then that whole thing here is raised to another exponent. Okay? The power rule tells me then that I'm going to take these two exponents and I am going to multiply them together. So I would take the x and the y and I would multiply them together. My base here still stays the same. So if I have x to the third all squared, oh, there's something missing here. That's not right. So you need to change that. My base stays the same as x. And then since I have a power raised to another power, I'm going to multiply them. 3 times 2 gives me x to the 6th. The quotient rule, if I'm dividing two exponents, again like the product rule, they must have the same base. Here a and a. If they do have the same base and I'm dividing, then I'm going to take those exponents and I am going to subtract them. So x to the 19th divided by x to the 12th. Again here, I do have to check. My bases are the same. They are both x. So that's going to stay in my answer, x. And then I'm going to take and I'm going to subtract these exponents. 19 minus 12 gives me x to the 7th power. The next one is power of a product rule, which says if I have really two bases, such here as a and b, that are being multiplied, and then both of those are being raised to an exponent on the outside, I can take that exponent and I can distribute it to both bases. So that would be a to the x times b to the x. So if we look at this example, 3x squared raised to the third. What I'm going to do is I'm going to take this 3. Now we got to be very careful. It goes to everything in the parentheses. So it's going to go to that base of 3 there. That's where this 3 to the third comes in. Then it's going to go to this x squared, and that's where the x squared to the third comes in. Then we're going to simplify. 3 to the third. You can take out your calculator if you need to, but all that means is 3 times 3 times 3, which is 27. And then we've got an old rule, a power rule. X squared to the third. I have a power raised to a power here. So I'm going to multiply 2 times 3, which gives me x to the 6. Our next rule is negative exponents. We never want to leave our answer with a negative exponent. So to get rid of a negative exponent, we move its position. So right now, a to the negative x is over 1. So to get rid of that negative exponent, since it's on the top, I'm going to move the whole thing, all of it, down to the bottom of the fraction. And then when I move it to the bottom, there's nothing left on the top, so 1 has to hold its place value. Now, if something has a positive exponent, you're not going to move it. It stays the same. So what's going to happen here in this example? X to the negative third, y to the fourth, over x to the fifth, y to the negative second. So I'm going to find my negatives. So this x to the negative third, I can't leave that negative, so it's got to move. And it's going to move to the denominator. Then I have y to the negative second. I can't have that negative exponent, so it's going to move to the opposite, which is the numerator. Now the y to the fourth here and the x to the fifth, since both of those were positive, they don't move. If you look, both of them came directly over right in their same position. So I've got y to the fourth that stayed. Y to the negative second, since it moved up, it became positive. That's the whole reason we moved it. And then on the bottom, we have x to the fifth and x to the negative third. Since we moved it down, it becomes positive. That's the whole reason to move them, is to get rid of the negative. And then if we look on top, I am multiplying these. They have the same base. Both of them have y's as their bases. So I'm going to use that product rule, which then tells me to add the exponent. So I'm going to get y to the 6. And then on the bottom, I have the same base of x. So I can add those, and I get x to the 8th. And then that is our answer. The next one is probably the easiest rule, but for some reason, it's the most missed. Anything to the 0 power, no matter if it's a number, a variable, or anything, is always 1. So if we look at this example, first of all, I have this power of 0 out here. Okay. Well, this whole thing is raised to the 0 power. Anything raised to the 0 power is 1. Does not matter. Okay, and the last rule, power of a fraction rule. If I have a fraction in my parentheses and it is raised to a power, then I'm going to take that power and I distribute it to both the top number, the numerator, and I distribute it to the denominator. So it's going to be a to the x over b to the x. So if we look at this example, x squared to the third, so I'm going to move it to here. That's going to give me this x squared to the third. And then the 3 is also going to go to this y to the fifth. So I have y to the fifth to the third. And then I have a power to a power, 2 exponents. So our rule is to multiply those. So my x stays as my base on top. 2 times 3 gives me 6. Y stays as my base on bottom. And 5 times 3 gives me 15. So that's my answer. So we're going to look at a few examples together, and then I'm going to give you an assignment to do today. So our steps into doing these. First thing we're going to do is apply appropriate exponent rules where applicable. Okay, whichever one's applied to this situation. Simplify numerators, denominators, and then we got to make sure that our final answer does not have negative numbers or exponents. If it has negative exponents, then they have to move positions. Okay, so let's look at this first one. 3x to the fourth times 2x to the third. So since I am multiplying these, what I do is I multiply the 3 and the 2, which gives me 6. I do have like bases here, x and x. And since these are being multiplied, I'm going to take the exponents. And the rule says if I'm multiplying with the same base, I add those exponents. So my x is going to come over as my base, and 4 plus 3 gives me 7. So 6x to the 7th would be my answer. Okay, this next one is a fraction, a division problem. So the first thing I'm going to do, and I always have students every year miss this part too, is I'm going to take my number part and I'm going to simplify it. 10 over 12, 2 goes into both of those. 2 goes into 10 5 times, and 2 goes into 12 6 times. Okay, so I did my number part, simplifying just like you would simplify a regular fraction. Now what I do is I subtract. Now here's how I kind of do it so I don't have to mess with negatives. If I have 4 A's on top, okay, if I have A times A times A times A, and then I have 8 of them on bottom, let me write that out. 4, 5, 6, 2, 4, 6, 7, 8. Some of these things cancel out. Okay, this A on top with this one on bottom cancels. This one and this one cancels. That one and that one cancels. That one and that one cancels. So I'm subtracting. How many A's do I have left? I have 4 of them left. Where are they found? They are found where the biggest exponent was, which was on the bottom, the 8. So I get A to the 4th that is left on bottom. I'm still subtracting. 8 minus 4 is 4. But I'm going to put my answer where the biggest exponent was to begin with. So same thing with the B's. I'm going to do the biggest minus the smallest. 7 minus 5 is 2, so I get B squared. It's going to go on top since the 7 was the biggest exponent. B squared. And then that is my answer. I can't do anything else. Okay, example 2. Doing the same thing. Answer should have positive exponents. First thing I'm going to do before I get started with this thing is I'm going to move negatives. I always move negatives first, which is only at the top. So I'm going to rewrite this problem as 18b squared c to the 6. That a to the negative third is going to move to the bottom here. Then we'll have 24a squared. I'm going to put in that a to the third that moved to the bottom. Then I have the b to the 5th, and c to the 4th. First thing, I'm going to worry with these numbers. 18 over 24, what goes into both of them? 6 does. 6 goes into 18 3 times, and 6 goes into 24 4 times. Okay, so we got a few things. I don't have any A's on top, but I do have A's on bottom. I have a pair of them right here. Since they're being multiplied, we add those exponents. So that's going to give me a to the 5th on bottom. Then I'm going to look here. I have b squared on top, b to the 5th on bottom. Since this thing is a division problem, okay, we are going to subtract these. So I'm going to do the biggest minus the smallest. 5 minus 2 gives me b to the 3rd. But where does my b to the 3rd go? It's going to go on the side where the biggest exponent was. That would be the 5. So b to the 3rd is going to go to the, or stay on the bottom. And then I have c to the 6th and c to the 4th. Again, I'm going to subtract them. 6 minus 4 gives me 2. Now, do that c squared go on top or bottom? It goes on top because that's where the most c's were to begin with. So, c squared. And that is our answer. And then for our last example, if we look out here, I have this exponent out here outside the parentheses. So that 2 is going to distribute to every single thing in this problem. It's going to go to this whole number 2, x to the 5th, y to the 3rd, z to the negative 2nd. Also goes to the denominator, to the 5, to the x squared, and to the y to the 4th. So this thing's going to look like 2 squared, and then x to the 5th squared, then y to the 3rd squared, and then z to the negative 2nd squared, all over 5 squared, x squared squared, and y to the 4th squared. Okay, now we got to simplify all of this down. I'm going to work this out. 2 squared, 2 times 2 is 4. X to the 5th squared, that power to that power, we multiply them. Gives me x to the 10th. Y to the 3rd squared, another power to the power, we multiply, gives me y to the 6th. And then for my z, I multiply those and I get z to the negative 4th. Over 5 squared, 5 times 5 is 25. Got this power to the power, so that gives me x to the 4th. And this power to the power with the y gives me y to the 8th. I am not done. I got several things I need to do. I can't leave negative exponents, so I'm going to get rid of that first. This z to the negative 4th is going to move to the denominator. So that's going to leave me with 4 x to the 10th over y to the 6th. And then 25 x to the 4th, y to the 8th, and z to the 4th. Now, I can't leave x's and y's on top with x's and y's on bottom. Okay, I've got a division problem here. The 4 and the 25 this time cannot be reduced, so we just leave it. Now, look at my x's. I've got 10 on top, 4 on bottom. So, what's the difference in them? X to the 6th. And it's going to go on top because that's where the majority of the x's were to begin with. X to the 6th. Okay, then we're going to look at our y's. We had 6 on top, 8 on bottom, so we have 2 left over. The majority goes on the bottom, y squared. And then the z doesn't have any z's on top, so it's just going to say z to the 4th on bottom. And that is our simplified answer. Now, what I want you to do is on the next page, you need to print this out, or you need to copy it down on another sheet of paper. This is your daily practice for today. You are going to work these out. And then you need to, on Google Classroom, it says you need to then take a picture, whether you printed this page out and did them on this page, or if you wrote them out on your notebook paper. And once you work them out, you need to take a picture and upload it onto Google Classroom and send it to me for your daily practice. Okay, there are also 3 IXLs that you have for this lesson. So once you get your daily practice turned in, you need to go ahead and get started on those IXLs.